To our music comprehension experiment, combining music with math by Sacred Swindell, Jalen Taylor, Brandon Yarborough, Ashir McCutcheon, and Vignesh Nair. So the reason that our group performed this experiment was to see if kids perform better on assessments when listening to music. And our research question was, will music help students do better on assignments?
We believe that the group that listens to music will perform better than the group that does not listen to music. Yes, we had randomization because we had them randomly draw the class that they were going to be in. We did not have a sufficient number of subjects because we only had a total of 9 students in each class. Yes, we compared the results of the kids' music to the ones that did not have music.
The lurking variables might be copying slash cheating, classroom environment, and did the students ever learn the material they were tested on? Who's blind? There is no evaluator blindness in this experiment. The subjects we used were blind to some extent because they did not know that they were going to be compared to other students. They did not know what the treatments were, and they only knew they had to take a test. Table of data and others. This is the data for the number correct for music and no music, and this is the dot plot. What can you learn from the two treatments by looking at the two dot plots? We learned that the data from the group with music is more varied and widespread, and that we don't really have any outliers. Outliers might mean that someone might have just been smarter than the others, and that there have been lurking variables.
The mean of the music group was 4.57, and the mean of the non-music group was 4.29. The difference was 0.28. As you can see, this is not enough to conclude that listening to music, the group that listens to music is better than that will help you better perform on a test. The standard deviation for music was 3.5, and the standard deviation for non-music was 3.72. This is a graph of our this is our graph of randomization distribution.
What can you learn about the two treatment comparing the means? We can learn that the treatment given doesn't necessarily affect the grade that the kids got. We just know that the treatment may have been more pleasant than the other. What can you learn about the two treatments by comparing the standard deviations? You can learn how close the data was to the average, so the music group showed us that the data was closer to the data. Looking at our randomization distribution, our hypothesis was wrong because we found out that the data was not significantly important. The treatment was not effective because the overall grades were pretty much the same. Because of this, we had to attribute the our results to chance.